Hey, how's it going? So, my name's Chad Houston, and if I can get this out of the way here, I'm going to tell you about the IMF Lab. Here's the deal. We are trying to figure out how and why things evaporate the way they do, and it mainly has to deal with the intermolecular forces or how well things like to stick together. So, here's what we're going to do. First of all, you're going to need a couple of these little chemicals. They're in these little vials. We got methanol, ethanol, propanol, butanol, and hexane. Okay. The next thing you're going to need is a GoLink vernier GoLink that's going to attach right to your Chromebook. Here it is. Now, what I've done, this is basically a temperature probe. What I've done is I've taken a little piece of filter paper, put it around the end, and I've wrapped a rubber band around it. That's kind of the hardest part. Put the rubber band on first, put it down, you put the paper on, and then you slide it up around the paper, and that's on that way. So here's the plan. I'm going to show you the software that you'll use, which is in the Chrome Web Store. You're basically going to take your probe, okay, pull up the software, we'll set the time on it, stick it in the liquid, wait about a minute, okay, and then what you want to do is hit collect, and then carefully count to 3, go 1, 2, 3. You'll take it out, set it off to the side, and it's going to evaporate. And as it evaporates, it takes the heat from the temperature probe in the paper to have it go from a liquid to a gas. We'll stop it when we're finished, when it's bottomed out. You want to hit the stats button, and then after that, you want to get the difference. So we're going to try and do a quick little dry run so you can kind of see how this works. So first thing I'm going to do is to go down to, let's see, you want to go down to the Chrome store. We want to get the graphical analysis. It's going to pull up, and one of the things you should see here is sensor data collection. Hit yes, and we did, and there it is. Now, first thing we'll need to do is to change the time. You want to change the time to about, let's say 300 seconds. So that should be more than enough. There we go. So we got 300 seconds. We'll hit done. The next thing that's kind of nice, although you don't have to do this, it's sort of nice to show graph and a table, just because it kind of shows us what's going on. What I'm going to do now is I'll take, put the thing in the methanol. I'm waiting about a minute just to kind of sit tight and so everything equilibrates, make sure it's all at the same temperature. I now hit collect, okay? And as I hit collect, I'm going to say 1, 2, 3. I now take it out of the sample, and I'm just going to lay it on the side of the table. Don't touch it and do not hit stop, okay? And as you can see, it's getting much colder. This is the same thing that happens when you step out of the shower. Basically, the water on your body evaporates, taking the heat with it. So you get colder, and we're seeing the temperature probe get colder. So now I'm not going to let this go the whole way, but what we would love to do is to wait when this hits rock bottom, and then hit stop. Now, I'm going to hit stop now because I want you to get the data. So after you hit stop, okay, we've got that. You want to go down here to right down here at this little graph tool button, open this up, and this is the big one, view statistics. And the number one thing you would like to get is basically these things right here. You want to get the minimum, which is the lowest temperature, and the maximum. Now, and essentially it even does the work for you. It finds the change in temperature. That's what we want. Now, the way you'll do it is you want to let this go the whole 300 seconds. You want to let it bottom out and find the difference. And what we'll do is we'll see not all chemicals evaporate the same. The ones that quote unquote stick together more are going to evaporate and take a lot longer to evaporate, and we'll see a lot less of a change in temperature. Why is that? Well, that's what we're trying to ask. Thanks a lot. If you have any questions, please do not hesitate to ask. So there you go, and